In this lesson, we are going to talk about product rule. Our goal is developing a formula for derivative of a function which is in the form of multiplication of two functions. In our previous lesson, we proved derivative of f of x equals c when c is constant is 0. Derivative of f of x equals mx plus b is m. Derivative of xn is n x to the power of n minus 1. Derivative of addition or subtraction of two functions is addition or subtraction of the derivatives of the functions. Derivative of a constant times a function is the same as constant times derivative of the function. In this lesson, we are going to prove the derivative of f of x times g of x is f prime of x times g of x plus g prime of x times f of x. We know f prime of x is limit of f of x plus h minus f of x divided by h as h approaches 0. Let's assume h of x is f of x times g of x. Then h prime of x is limit of f of x plus h, g of x plus h, which is h of x plus h, minus f of x times g of x over h as h approaches 0. We rewrite this limit as limit of f of x plus h times g of x plus h minus f of x times g of x plus h plus f of x times g of x plus h minus f of x g of x over h as h approaches 0. Basically, we add and subtract f of x g of x plus h in the numerator of the quotient difference, and we try to split it into parts. If we factor g of x plus h between the first and second term, the limit can be written as limit of g of x plus h times f of x plus h minus f of x over h plus f of x times g of x plus h minus g of x over h as h approaches 0. We know limit of addition of two functions is the same as addition of the limits. Therefore, this can be written as the limit of first part plus limit of the second part. Limit of multiplication of two functions is limit of the first function times limit of the second function. The limit of the first function is g of x, and the limit of the second function is f prime of x in the first part. In the second part, we use limit of multiplication again. Limit of f of x as x approaches 0 is f of x. It's constant basically. And limit of g of x plus h minus g of x over h as h approaches 0 is g prime of x. Therefore, the derivative of f of x, g of x is f prime of x, g of x plus g prime of x, f of x. This can develop to more than two functions. If h of x is f of x times g of x times h of x, h prime of x is going to be f prime of x times g of x h of x. We split it in two parts, plus derivative of g of x h of x times f of x. This is the same as f prime of x, g of x, h of x, plus f of x, g prime of x, h of x, plus f of x, g of x times h prime of x. Notice that the derivative of g of x times h of x is g prime of x, h of x, plus h prime of x, g of x. Let's have an example. Let's find the derivative of 5x2 times 7x2 plus 9x plus 3 in two ways. One way using the product rule. The first function is 5x2 and the second function is 7x2 plus 9x plus 3. The derivative is 10x times 7x2 plus 9x plus 3 plus 14x plus 9 times 5x2. This can be written as 70x3 plus 90x2 plus 30x plus 70x3 plus 45x2, which is the same as 140x3 plus 135x2 plus 30x. We can find the derivative of the given function by multiplying the two functions, 35x4 plus 45x3 plus 15x2. The derivative of the first function is 4 times 35, which is 140x3. 3 times 45 is 135x2 plus 30x. Using both methods, we have the same final answer as it's expected. Thank you.